Okay, so let's look at this question. So on a dark night, two ships, okay, I can't quite make out their names, but they sail parallel to a straight coast, something something, on which there are two lights of equal brightness, 16 kilometers apart. Okay, so we have like a y-axis and an x-axis. We have an origin, and we have a point at 80. Okay, so that's the 16 apart with the minus 80. Okay. It's a dotted line. Here, the point P, xy, no, xb. It's fixed at a height b, and it said that this is the length b. Okay. Okay, so parallel to the coastline, on which there are two lights. So this must be the coastline, right? And then that must be the ship sailing parallel to the coastline. There's two lights. It says light 1, light 2, 16 kilometers apart. Okay, good. Equal brightness. Okay, suppose the coastline is represented by the x-axis. We figured that out, where the origin is chosen to be the midpoint of the light sources. Okay, so that we've done that. It is known that the total brightness from the lights on the ship, lights on a ship at point P, is given by some funky formula. So I equals 1 over, okay, I can't read that. B squared plus x plus something squared plus 1 over b squared plus x minus something squared. I feel like it should be 8. Okay, I can't quite really make out what this is, but what is b squared plus x something? So that seems to be the distance. So if it was just x squared, it'd be the distance from the origin to P, right? But it seems to have something to do with the light, so maybe it'll be the distance from the lights to P. Okay, so it's the inverse square of the distance squared. Inverse square of the distance. So I would guess this to be 8. Okay, even though I can't read it. And that appears to be the question. So the first part says, show that di dx equals something. Okay, and that should be routine, okay, because it's already in terms of x and it's something you can differentiate. B is a constant, okay? So that shouldn't be a problem as long as you work through it diligently. Okay, to answer part 2 and 3, assume P is factorized. So one of the ships sails parallel to the coast at a distance 15 kilometers from the coast. By considering the derivative, show that as the ship sails from left to right, the brightness increases to a maximum when x equals 0, and then decreases. Okay, so another ship sails, then that's the next part, another ship sails parallel to the coast at a distance 6 kilometers, so I guess this is where we let b be 15 or 6, okay? Describe how the brightness on hero changes as hero sails from left to right. Give clear reasons for your answer. Okay, so I mean, it doesn't seem like we'll need to go too far outside the box here. As long as we do this correctly, and which we'll know we will because it tells you what the answer should be, right? Then we just have to sort of see what they're getting at and provide the reasons. Okay.